Okay, so let's do this. Doing an example as a review for chapter 5.3 before we move on to trig equations. Seeing as how I have rearranged, or rather factored out the two so that I have A, K, D, and C clearly visible, I'm going to approach this using the box method. C, positive 3. So I'm going to put my transversal axis, or the mid-axis, at 3. Next, I'm going to stick with my green pen. The amplitude, or rather the A value, is a -1. So yes, I have to keep in mind it's a negative, but how far up and down am I moving from the transversal? 1. That's my ceiling, and this is my floor of my box. Next, my K value will tell me something, but first, let's do the D. I will use red this time. I am moving pi over 2 to the left side. This is going to be my start. And then I apply the K. How does that help me find the finish? Well, my new period is going to be my old divided by K, which means that is 2 pi divided by 2. My new period is going to be 1 pi. Sorry, give me a second. Great. So from here, figure out how many boxes I must move for a single pi, and then draw your finish line. 1, 2, 3, 4. Okay. So with that, do I have a highlighter with me? I do not. Whatever. Okay. So you see this box, and I need to draw a single cosine curve inside that box. But please be careful, there is a negative. So normally, I would have my curve go from maximum to minimum and back to maximum, because that's a regular cosine curve. If you remember, it's like that, right? So it should have the same shape. However, the negative means that this is going to be upside down, so my first point is actually at a minimum, and then I also finish at a minimum. And in between must be a maximum. And again, I am going to ask you to use your I guess spatial visual abilities. Between the lowest point and the highest point, right in the middle of the lowest and the highest point should be another, and then another. And then with these 5 dots, you do your best to create nice curved sketches, curved lines. And we successfully have sketched 1 cycle. And from here, you could literally just copy and paste it if they want 2 cycles, or 3 cycles, or 4 cycles. So it would be like X, 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 so on and so forth. You draw nice curves, whatever. Okay, I'm just being extra here. You don't have to do all that, you just have to draw 1. Yes, Zach? The old period, it always starts with 2 pi, a full rotation, right?
So the old period is always 2 pi regardless of the graph?
Of course. Well, I could do a thinking question. What if I gave you a curve that's already transformed? Right?
Oh, and then you actually back.
Yeah, so like whatever the old is whatever you're starting with. But anyways, I don't think I would be doing that to you anytime soon. At least not for this quiz. Yes? On the worksheet, I have something different. That's not good. Let me take a look. My bad. Let's take a look. Where is my drive? Course resources. 5.3. Examples filled. Ah, I only moved pi over 4. Yeah, that is bad. Oh, that means I gotta do a full answer key again. Oh. Okay, I'll see if I can white it out. Okay, thank you for that. I'll put a little star next to this one. Alright, let's move on. So using this Mox method, let's see if we can decipher a question like this. I give you, let's do, I don't know, which one looks hard? Okay, example 1 or example 3? What would you like? Yeah, let's do 3. Let's say I give you an obscure graph like this, and I only give you 2 points. Well, as long as we have AKDC, I don't care. I can sketch this. So let's figure it out. Don't worry whether it's sine or cosine. That all depends on where you want to start this curve. Let's first begin with drawing your roof, your ceiling, and your transverse axis. My maximum is a -1. My minimum is a -4. And if I look carefully, I can draw out my transverse axis, and that looks to be about -2.5. Right off the bat, my C value is the transverse axis, -2.5. Right? It corresponds with that midline. Also, what's my amplitude? Don't worry about the plus or minus. I'm looking for a number. Yes? Pardon? 1.5? Good. Again, I don't know if it's plus or minus yet. But in fact, you can choose depending on where you want your curve to start. Next, what's my K value? Bless you. Please note, by formula, I'm not going to get it wrong this time, old divided by new. So what is my new period? It might be a little hard to make out. What do you think, Vishaka? 3? Are you sure?
Oh, sorry, the period's 4 pi
4 pi
over 6.
over 6. I don't know. Tell me, how did you get that?
Well, I looked at the like one cycle.
Mm-hmm.
Just counted the
Oh, interesting. Well, how did you count? Because right now the units are really weird, right? It's 2468. It doesn't give it to you in pi or 2 pi and whatnot. So it's meant to be a little confusing. So I'm forcing you to use these values. How might you use these values? 0 and pi over 6. Use it?
Multiply by 4.
What do you mean multiply what by 4?
That section. Pi over 6.
Pi over 6. Right, so let's pretend we start our curve here. From the midpoint to the maximum, in other words, this part right here, you can say that this part is exactly 1/4 of a period. Right? So this part is equal to 1/4 of a period. And how much is that? As you were suggesting, 0 to pi over 6. 1/4 of a period is pi over 6. So what is a full period? Times 4, right? 4 pi over 6 or 2 pi over 3. So the new period is, I'm going to bring it right back up, 2 pi over 3. If you divide 2 pi by a fraction, it's like multiplying 2 pi with the reciprocal. The k value is going to be 3. Lastly, the d value depends. Where do you want to start the curve? If you want to start the curve right there, then we're dealing with a sine curve. If we want to start the curve from here, we're dealing with a cosine curve. If you want to start the curve in the middle, but it goes down, well, we're dealing with a sine curve that has been reflected. If you want to start the curve at the bottom, at the minimum, we're going to be dealing with a cosine curve, but it's been reflected. It's up to you, really. Anyone have a burning desire to start in a particular location? Yes, Yusuf? I have a feeling your burning desire is to make it as easy as possible. Okay. Then I would say, why not start here, because it's already on the y-axis. The x value is already is a 0, so I don't have to move anything. But if I say that there is 0 horizontal shift or 0 phase shift, then I am automatically forcing myself to start here, which means this is 1 cycle. Which means I am dealing with a sine curve and not a cosine curve. So what you have chosen as your phase shift automatically determines whether you're starting from a max, a min, or a middle. Okay? Therefore, putting it all together, f of x is equal to positive 1.5, it's not reflected, sine 3x minus 0 minus 2.5, not plus, minus. Let me write that nicely. Do I have white out here? No? Why not? Okay. Any questions? Okay, so these are the kinds of. Oh, yes, Maxim. Sorry, Mason.
Why we, like, I understand why pi over 6 was multiplied by 4.
Y pi over 6.
Like, to find the new period.
Uh-huh.
I'm just confused why we know pi over 6 was a quarter. Like, why was it?
Based on logic. We see that the curve is starting at 0 and hit a maximum. Automatically, on a regular sine curve, we know that's going to be 1/4 of a cycle. For example, right? If we go from, oh shoot, this is a cosine curve, sorry. Let's do sine curve. Regardless of how I transformed it, if I go from the middle to a maximum, automatically that's 1/4 of a period. So, yeah, it's a logic piece. Yes?
How did 2 pi over 3 turn into 3?
Sure. 2 pi divided by 2 pi over 3 is the same as 2 pi divided by 2 pi over 3, which is the same as 2 pi times 3 over 2 pi.
So whenever we get the
I don't like the idea of forgetting, because that sounds like magic. What we're doing is dividing a fraction. And when you divide a fraction, it's like multiplying the reciprocal. And when you do that, the numerator and denominator, they can reduce. They can divide into 1. So 2 divided by 2 is 1, and pi divided by pi is 1. All that's left is 3. No, it could be anything. This could be 2 pi over 1 million. Right? You're dividing by a fraction, so you're multiplying the reciprocal. All right. Yes?
Can you go over phase shift again, like D?
Phase shift? As in horizontal shift? The D value?
Yeah, I didn't really get that.
Okay, I'll say it one more time. The D value is essentially up to you. Because the function is constantly repeating itself, you can choose wherever you want to start the curve. So you tell me. Let's pretend, I'm going to use another piece of paper. I hope nobody needs another copy of 5.3. So the question was, the D phase, how do you know it's a 0? It's not that you know, it's that you choose. Because this curve repeats again and again, there's a gazillion different answers you can give me. And all of them are correct. Okay? Because it repeats. So let's pretend you want to be a little different, and you chose your starting curve to be, I don't know, let's pretend it's that. You chose your starting curve to be pi over 6. Right? So once again, my A value is 1.5, the absolute value. The C value is negative 2.5. My K value is a 3. And you're going to say, you know what? I'm going to pretend I moved pi over 6 to the right. And that's going to be a maximum. What that means is my function is now going to be 1.5 cosine, because I'm starting at a maximum. But because I'm starting at a cosine, you have to have a shift, because it's a maximum. So now, instead of consider the previous example before, am I doing it right? Do you notice where the red part is on the top curve? On the bottom, my red curve is right here. That's the first 1/4. That's the first quarter of my curve.
If you were doing it with cosine earlier. If you were making it a cosine curve.
Yes. So because you chose to start, why is it like auto unfocusing? Because you chose to start at a maximum, this is now 1 cycle. And notice how it is different from where this one ends. You see how it's a little bit shifted?
Yeah.
And we call it a cosine because of that. Does that mean the picture is different? No, they're both sinusoidal. It's just a matter of where you chose to start your cycle.
Would you start it, so would you have the option to start at 0 or the maximum, and that's it? Like if you were to start from the
Well, yes, because sine starts at as in a middle, and cosine starts at a max, right? So it's going to be one or the other if you want to use the cosine as, or if you wanted to express it as sine or cosine. Yes.
So like we know the function down, if we started in the middle at like minus, if we started at 0, minus 3, whatever that was.
Yeah, minus 2.5.
No, not the one underneath this.
This one?
Yeah.
Uh-huh.
We started a little bit to the left. Or is this the same question?
Yes.
Oh, okay.
I'm just trying to show you that if some people might answer this question with sine, some people might answer with cosine. They are both correct.
I just thought start at the origin, but I didn't realize they were the same question.
Yep. Yes.
You probably won't do this, but could you like start at it looks like it hits -4. Could you start there and do sine and then have your g -4?
Are you saying, can you start your curve here? Where?
No, -4 on the x-axis.
-4 on the x-axis, right here.
Yeah.
Absolutely. It wouldn't be -4. It would be, let's see, 2 pi over 3 this way, 2 pi over 3 this way. It would be 4 pi over 3. And yes, you can say that this sine is 1 over 1.5 sine 3x minus 4 pi over 3 minus 2.5. Get the same thing. Yes?
Okay, last little hypothetical. If you were to start your cosine function on the minimum, like if you were to go back and have it start on negative pi over 6,
Uh-huh.
would that mean that it's reflected because you're starting it on the minimum rather than...
So you're starting here this time?
Yeah.
Yes.
So you would flip it and the
Very good. Correct.
coefficient would be negative.
So if this is pi over 6 to this side, another quarter to the left would be negative pi over 6. This would be negative pi over 6 comma negative 4. Right? So if you wrote to me that it's 1.5 cosine 3x plus pi over 6 minus 2.5, you would be correct, except, let me use green. You've started your curve right here. I know that it's really messy, but you started your curve here and you finished here. That's an upside down cosine. So there would be a negative, yes. So you see, there's literally a million different answers you can give me, and they're all correct.
And are there things like this on the test? Something like a long...
I might give you an equation and ask you to give. So I could give you a curve and ask you to give me any equation, right? And they're all equal. So I would be happy to accept them all. This is good. But I spent the first 45 minutes on it. So let me pause. Let me stop here, and I'm going to hand out 5.4.